everybody, welcome to our week 13 quiz tutorial. So the first thing I asked you guys to do was to solve an equation with rational expressions in it. So we have 7 over 3x plus 6 minus 5 over x plus 3 equals 9 over x squared plus 5x plus 6. These ones can look a little daunting at first, but if you just take it one step at a time, I promise they're very, very doable. And the first thing you're going to want to do is get it out of those rational expressions. And the easiest way to do that is to multiply everything, so that's both sides of your equation, by your least common denominator. So let's figure out what our LCD is first, and we can go from there, okay? So my denominator of my first rational expression, the 3x plus 6, that factors as 3 and x plus 2. My next denominator is just an x plus 3, so that doesn't factor at all. And my last denominator is x squared plus 5x plus 6. That one factors out as x plus 3 and x plus 2. So my least common denominator, if you remember, has all of the factors from all the denominators, the maximum amount of time that it ever occurs. Okay, so for my first denominator, I need a 3 and an x plus 2. From my second denominator, I need an x plus 3. For my last denominator, I need an x plus 3, which I already have one of those. I need an x plus 2, and guess what? I already have one of those too. So this is our LCD. Our least common denominator is 3 times x plus 2 times x plus 3. So what you can do is multiply both sides of your equation by the same thing, and I'm going to be strategic about it so that it helps me, and multiply by that LCD. So I'm going to multiply everything by 3, x plus 2, and x plus 3. And that's both sides. It's every single term on both sides. And this step, just take it one term at a time, and I promise it's going to end up okay. Just don't rush through it, okay? So my first denominator, the 3's are going to divide out, and the x plus 2's are going to divide out. So those two things divide out, and you're just left with an x plus 3. And then that's going to multiply by my numerator, which is a 7. So I'm going to have 7 times x plus 3, and then those denominators completely divided out, which is exciting. Okay, so that's what your goal is in this step is let's get rid of the denominators to make our life easier. Okay, see, we had a minus sign here, and we still do. In that second term, the x plus 3's divide out, so no denominator anymore. And then you're going to have a 3, an x plus 2, and a 5 that are all going to multiply together. So I think we can start multiplying. At least 5 times 3 is 15. So we'll have 15 times x plus 2. There was an equal sign. There's still an equal sign. Last term here, the x plus 2's are going to divide out. The x plus 3's are going to divide out. And you're just going to be left with a 3 here. And nothing in the denominator. Technically it's a 1, but everything divided out, which is very nice. You're going to have a 3 times 9, which would be 27. Okay. And look at that equation. Doesn't that look a whole lot better than what we started out with? I know. So that's the whole point in multiplying by the LCD, is you get a much nicer, prettier equation to solve. Okay. So from here, it's just regular equation solving, so we should probably distribute. 7 times x plus 3 would be 7x plus 21. That minus 15 times x plus 2, well, you're going to have to do negative 15 times x, which is negative 15x, and negative 15 times 2, which would be a minus 30. It still equals 27. I haven't changed that at all. We can combine some like terms, so 7x minus 15x would be negative 8x. 21 minus 30 would be negative 9, and it still equals 27. See, it's getting better and better all the time, isn't it? Run out of space, so I'm just going to keep going up here. So I've got negative 8x minus 9 equals 27. From here, let's add 9 to both sides to get rid of that minus 9. So now I've got negative 8x equals 27 plus 9, which is 36. And last but not least, we'll divide both sides by negative 8. Now, when you're typing this in my math lab, you're going to at least have to simplify it. I'm pretty sure that my math lab actually prefers it as a fraction and not as a decimal. So let's simplify it as a fraction, just to be consistent there. 36 and 8 is not perfectly divisible, but 36 and 8 are both divisible by 4, so we can simplify that to have x equals positive divided by a negative is a negative, and that would be 36 divided by 4 is 9, 8 divided by 4 is 2, so x would equal negative 9 halves. Or for those of you who really like mixed numbers, that's negative 4 and a half. Okay? With these rational expressions, you do have to check your answer at least a little bit. And in case you're wondering, why do you have to do that? You multiply both sides by variables, and because you multiply both sides by a variable, you run the risk of adding extra solutions to your solving at the end. And so those are called extraneous solutions if you're really curious. But the nice thing is that they always kind of correspond to the things that you multiplied by. So pretty much if this works out with your LCD, it's going to be fine. So with your LCD, the things that x can't be would be negative 2 and negative 3, because that would make our denominators a 0, and that would be bad. And negative 9 halves is not negative 2, and it's not negative 3, and it's going to work out just fine with all of our denominators, so it's not an extraneous solution. Yay! So at minimum, you need to do that check. If you've got time to actually plug it back in, I would do it, okay? Just to make sure that you got it right. But you need to at least double check that it works out with your denominators, okay? So that's the first one. Second one I gave you guys was a nice little word problem. We have Lou's copier can complete a printing job in 5 hours. Nora's copier can do the same job in 7 hours. How long would it take to do the job with both copiers? They're working at the same time, working on that copy job together. And your answer is going to be either an integer or a mixed number. Okay? Because that's what my math lab always asks for. So first thing, I just wanted to see your all's equation. How'd your setup go? So an equation to solve the problem. In general, this is a work problem, and work is equal to rate times time, okay? And so for Lou's copier, the rate, since it can do the whole job in 5 hours, the rate would be that it can do 1/5 of the job each hour. So the rate for that copying machine is 1/5. And I'll just use a t for time. That's what we're solving for. It says how long would it take. That's a time question. So we don't know t. We're going to solve for it. For Nora's copier, it can do the same job in 7 hours. So if she can do the job in 7 hours, her rate is going to be 1/7 because she can do 1/7 of the whole job each hour. So 1/7, and again, I'm going to use t for time. Okay? Those copiers are working together. They're not, holding each other back. They're not stepping on toes. There's hopefully no overlap of printing pages. They're working together, which means that we're going to add those works together to get our total. And then it equals 1 because we're doing 1 copy job. If they were doing 2 copy jobs, we would equal it to 2. Or 3 jobs of the same length, we would equal it to 3. But since we're just doing 1 job, it equals 1. So that is the setup. Okay. Next up, solve the problem. So let's solve it. So just like the last one we did, we should probably multiply by our least common denominator to get started. So if my denominators are 5 and 7, my LCD would be 35. So what I'm going to do is multiply both sides, and that's every term on each side, by 35. So that's 35 times 1/5 t. That's 35 times 1/7 t. And I'm also going to do 35 times 1, and I hope we're all okay with 35 times 1 is 35. Okay? Let's see, 35 times 1/5. Well, 35 times 1 is 35, and divide by 5, that would be 7. So I've got 7t. 35 times 1/7, so again, 35 times 1 is still 35. And 35 divided by 7 would be 5. So now I've got 5t. So 7t plus 5t equals 35. We can combine like terms. once my video catches up with me. There we go. Hello. Alright, 7t plus 5t is 12t equals 35. And last but not least, let's just divide both sides by 12. So then what you're going to get is t equals 35 twelfths, which is an answer, but it's not quite in the right format yet, because if you notice, I said to answer as an integer or as a mixed number. Okay, so that is not an integer, and it's not a mixed number. Okay, so let's make it into a mixed number. How many times does 12 go into 35? It goes in twice. It almost goes in 3 times, but not quite. 2 times 12 is 24, and so the difference between 24 and 35 is 11. So it'd be 2 and 11/12 hours. That's the answer my math lab likes. Now, if you were talking to a regular person, I don't think they would like that answer very much. In case you're curious how to get from there to minutes, what you do is you take 11/12 and you multiply it by 60, because there's 60 minutes in an hour. And in case you're curious, that's 2 hours and 55 minutes. Which I am perfectly okay with you putting that on your quiz, because that would make a lot more sense to a person. But my math lab is looking for this one, okay? So I figure it's nice to know both ways, more than one way to answer a question. Alright, so that's number 2. Hopefully that answers some questions for you guys. Last one, I asked you guys as a review question because, it's been a little while since we did some graphing lines, and that's going to be on your final exam, amongst everything else. So let's do a quick review question. Write the equation of a line that goes through the point 4, -1, and is perpendicular to the line y equals 1/3 x plus 2. And we're going to give our final answer in slope-intercept form. Alright, so first thing I notice is that my line has to be perpendicular to this line, okay? Perpendicular lines have opposite reciprocal slopes. So the slope of the line that I gave you is 1/3, okay? The perpendicular slope is going to be opposite, so instead of positive 1/3, it's going to be negative. And it's the reciprocal. So the reciprocal, it looks like you just flip it around. The reciprocal of 1/3 is 3/1, or just 3. So I know that the slope of my new line that I'm writing the equation for is perpendicular to the line that I gave you, and has a slope of -3. So we know it has a slope of -3, and we know it has to go through this point 4, -1. Since I have a point and a slope, a great starting point would be to use point slope form. So point slope form is y minus the y coordinate, which would be -1, equals our slope, which is -3, parentheses x minus the x coordinate, so x minus the x coordinate, which is 4. That right there is point slope form, which is a really handy starting place. But it's not the format that I want to end up in. But it's a good start, because at least we're in an equation and we can move things around. Remember that slope-intercept form? That looks like y equals mx plus b. That's the format that I want it in at the end of everything, which means I don't want parentheses anymore. I'm going to need to distribute to get it out. And I want to get y by itself. Okay, so those are kind of my goals right now. So on the left side, I can simplify a little. Minus -1 is the same thing as y plus 1. On the right side, we can distribute. So that would be -3x. And -3 times -4 would be positive 12. So at least we're out of the parentheses and we're getting much, much, much closer. Okay? The only difference between where I am and where I want to be is that this has a y equals, and I have a y plus 1 equals. So to get rid of that plus 1, I'm going to subtract 1 from both sides. So now I'll have y equals -3x plus 12 minus 1, which is 11. That's in slope-intercept form, because I've got y equals my slope, which is -3, which matches what it should be, plus a y-intercept plus a nice number. So apparently it crosses the y-axis at 11 for the y-coordinate, so it'd be a 0, 11 point. But that is my final answer. Okay? Hope this helps you guys. Good luck this week.